What exactly are ACID transactions? Let's start with the first principles of ACID, which is atomicity. And atomicity is pretty straightforward concept. Let's break down with simple example. Imagine you are trying to withdraw money from your bank account. The third principle in ACID transaction is isolation, and it's all about making sure durability guarantees that once a transaction is completed, the data is permanently saved even if the system crashes right after. Hey everyone, welcome to PrepTrain YouTube channel. I am Sahib Kumar, and if you are new here, PrepTrain is a channel dedicated to helping you grow your skills in backend engineering, master key concepts, and ultimately refine your path towards becoming a backend pro. If you are just starting out or looking to level up, we have got you covered with practical tips, real world examples, and in-depth explanation of core concepts. And our goal is to make you backend engineering not just understandable but also exciting and accessible for everyone. Today we are diving into a super important topic, one that is absolutely essential for anyone working with databases. Have you ever wondered how your bank ensures that your money does not just get disappear in the middle of a transfer, or how an e-commerce platform ensures that your order does not get lost even if the system crashes? Well, it's all thanks to something called as ACID transaction. ACID transaction are the backbone of reliable database, and in this video I'm going to break down all about ACID and what ACID stands for and how it works and why it is so crucial for maintaining data integrity in everything from banking to social media. Trust me, by the end of this video, you will have a solid understanding of how these principles keeps your data safe and sound. Before we jump in, don't forget to hit the subscribe button and turn on notifications so that you don't miss any of our upcoming videos. If you find this video helpful, give it a thumbs up and let us know what you think in the comment below. Alright, let me bring my deck and then we will continue diving deeper into ACID transactions. What exactly are ACID transactions? Well, ACID is an acronym that stands for atomicity, consistency, isolation, and durability. These four principles are essential for ensuring the integrity of your data when working with databases. Whether you are transferring money, making online purchases, or updating your profile on a social media platform, ACID transactions are what keeps everything running smoothly behind the scene. Let me break it down in simple terms. Suppose you are transferring money from bank account to another, and you want to make sure that the transaction happens without any errors, right? So you would not want your money to disappear halfway through the transfer. ACID transaction ensure that either the entire process is completed successfully or nothing happens at all. It is a way of guaranteeing that your data remains safe, consistent, even if there is a system crash or some other issue. Databases uses ACID transaction to handle operations like banking transfer, online purchases, or even something as simple as posting updates on social media. Without these principles, we will be dealing with a lot of messy, unreliable data, and this is exactly what we don't want when it comes to handling sensitive information. By the end of this video, you will have a clear understanding of how each of these ACID principles work together to protect your data, and you will see why they are so crucial for backend engineers and how mastering them can help you build more reliable systems. Let's start with the first principles of ACID, which is atomicity. And atomicity is pretty straightforward concept, but it's absolutely critical to ensure the reliability of your transaction. Atomicity means a transaction is an all or nothing operation. Either the entire transaction is completed successfully or nothing happens at all. There is no middle ground. Imagine you are buying a phone online. You won't want your payment to go through and later you find out that your order did not process, right? This would be a nightmare. Atomicity ensures that either both the payment and order confirmation happens or neither does. It's all or nothing. Let's take an example to make it more clear. Let's say you are transferring 100 rupees from account A to account B. The system needs to subtract 100 rupees from account A and add 100 rupees to account B. Atomicity ensures that both steps are completed, and if for any reason one part of transaction fails, then a network error while updating account B, then entire transaction will be rolled back. So account A won't be debited and account B won't be credited, preventing any loss of data or partial updates that could cause inconsistencies. Think of it like an undo button. If something goes wrong during the transaction, the database just hits undo and it's like the transaction never happened. This is especially important in cases where multiple steps needs to happen for a transaction to be complete. It prevents half-baked or broken data from entering your system. Atomicity is essential for maintaining the integrity of your data, and without it, we could end up like incomplete transaction that could wreak havoc on your system, especially when dealing with large-scale applications like e-commerce platforms or banking systems. Now that we have covered atomicity, let's move on to second principle, which is consistency, and let's see how it makes sure that all of your transactions follow the rule of the database. All right. So the second principle in ACID transaction, consistency, is all about ensuring that every transaction leaves the database in a valid state. In other words, it makes sure that all the rules and constraints defined by the database are followed. Let's break down with simple example. Imagine you are trying to withdraw money from your bank account. The bank system has a rule in place that says your balance can't go below zero. If you attempt to withdraw more money than what you have in your account, consistency will kick in and prevent the transaction from going through. The transaction would simply be rejected because it violates the rule of the system. This is what we mean when we say that consistency ensures that only valid data is written to the database. Consistency is crucial because it prevents bad data from entering into the system. And imagine a scenario where a transaction violates a constraint, like entering a negative balance or breaking a foreign key relationship between two tables. Without consistency, these invalid states could corrupt your data and lead to major problems down the line. Think of it like this. If you were at a pizza shop and they had a rule that every pizza must have at least one topping, you would not be able to order pizza with zero toppings, right? That's how consistency works in a database. So if a transaction tries to break a rule, the system simply won't allow it. This principle ensures that database remain accurate and reliable no matter how many transactions are going on at once. It enforces the rules and keeps everything in check, making sure that your data stays in a valid state before and after each transaction. So to sum it up, consistency guarantees that all transactions follow the rules of the database, ensuring that your data remains valid and safe. Now that we have covered consistency, let's move on to isolation, another critical principle that keeps transactions from interfering with each other. Now, the third principle in ACID transaction is isolation, and it's all about making sure that multiple transactions happening at the same time don't interfere with each other. Imagine this. You and someone else are both trying to buy the last remaining ticket to a concert at the same time. Without isolation, it's possible that both of you could end up with a confirmation, even though there is only one ticket left. So that would lead to chaos. Isolation ensures that transactions are processed one at a time, even if they are happening simultaneously. In technical terms, isolation ensures that while a transaction is being processed, it is treated as it's the only transaction happening. This prevents one transaction from affecting another. For example, if two customers try to purchase the same item at the same time, isolation ensures that only one transaction will go through and the other will either wait or fail based on the system logic. Isolation is especially important in systems where multiple users are interacting with the database at the same time, like e-commerce platforms or banking systems. Without isolation, transaction could end up overwriting each other, leading to incorrect data or lost updates. Let's take another example to illustrate this. Imagine two bank tellers are processing transaction on the same account at the same time. One teller is depositing money while other is withdrawing. Without isolation, both transactions could happen simultaneously, leading to inconsistent data. But with isolation, the system ensures that one transaction is completed before the other begins and it prevents any conflicts. In databases, isolation is achieved through techniques like locking, where a transaction locks the data it's working on until it's finished. It ensures that no other transaction can change the data in the meantime. So to sum it up, isolation ensures that transaction does not interfere with each other even when they are happening at the same time. This is crucial for maintaining the integrity of your data in system where multiple transactions are happening simultaneously. Now that we have covered isolation, let's move to the final principle, which is durability. Durability guarantees that once a transaction is completed, the data is permanently saved even if the system crashes right after. Let's take an example. You are placing an order online. You have selected your items, entered your payment details, confirmed the order, but as soon you get the information, the transaction is durable. Meaning, even if the website crashes a moment later, your order is safe. The system has saved your order permanently and it's not going anywhere, no matter what happens next. Durability is critical because it ensures that only once a transaction is committed, it survives any kind of failures such as power outage or system crash. Imagine if you transferred money to someone and got a confirmation, but then the system crashed and your money just disappeared. This would be a disaster, right? So durability prevents this by ensuring that all committed transactions are saved to stable storage like a hard drive, meaning they will be there when the system comes back online. So in databases, durability is typically achieved using techniques like transaction logs, which record every change made during a transaction. If the system crashes, the database can refer to these logs to restore any committed transaction, ensuring that nothing is lost. To summarize, basically durability guarantees that once a transaction is complete, that the data is saved permanently and won't be lost, even if the system crashes right after. This is what makes your data reliable, giving you confidence that once a transaction is confirmed, it's here to stay. Now that we have understand the fundamentals of ACID transaction, let's explore some real world use cases where these principles are applied every day. So ACID transactions are everywhere, from banking to e-commerce to social media. Let's break down a few examples to give you a better sense of how important they are. Imagine transferring 500 rupees from your saving account to your checking account. Atomicity makes sure that either both the debit and credit steps happen or neither does. If system crashes after debiting your saving account, the transaction will roll back. No money will be lost. This prevents situation where one account is debited but the other is not credited, which could lead to serious problem. Now let's look at e-commerce. When you are buying something online, consistency ensures that the stock levels are accurate. Let's say you add an item to the cart, but there is only one left in the stock. If someone else is also trying to buy that item, isolation ensures that the transaction don't interfere with each other. Only one person will successfully buy the last item and the other transaction will either wait or fail. This prevents two customers from accidentally buying the same product. Finally, let's talk about social media. When you post a photo or update your status, durability ensures that once the post is confirmed, it's saved permanently. Even if the app crashes a moment later, your post is already saved and won't be lost, no matter what happens after you hit the post button. So these are just a few examples, but ACID transactions are at the heart of many systems we use every day, whether it's managing your bank account, checking out any e-commerce site, posting on social media. ACID ensures that your data is handled safely and reliably. Alright, now that we have covered each of the four principles of ACID transaction, let's quickly recap everything that we have learned. These four principles, atomicity, consistency, isolation, and durability, work together to ensure that database remains reliable even in most complex systems. Let's start with atomicity. This principle guarantees that a transaction is all or nothing. Either every part of a transaction is completed successfully or none of it is applied. This prevents incomplete or partial updates, ensuring that your data remains consistent and error-free. Remember the example of buying a phone online. Either the payment goes through and the order is confirmed or neither happens. So atomicity ensures that there are no half-list transactions. Next, we have consistency. This principle ensures that all transactions follow the predefined rule of databases. Think of it like the gatekeeper that prevents invalid data from being written to the database. For example, in a banking system, you can't withdraw more money than what you have, right? Because consistency ensures that transaction follows the rule of keeping account balances valid. Then we talked about isolation. Isolation ensures that even if multiple transactions are happening at the same time, they don't interfere with each other. This is especially important in systems where multiple users are interacting with the database simultaneously. Remember the example of two customers trying to buy the last item in the stock. So isolation makes sure that only one transaction affects the inventory at a time. And finally, durability. Once a transaction is completed, durability guarantees that the data is saved permanently, even if the system crashes right after. So durability ensures that your data is safe and won't disappear, giving you peace of mind that once a transaction is committed, it's here to stay. So to sum up, ACID transactions are the backbone of reliable database. They ensure that your data is safe, consistent, and protected even when things go wrong, whether it's a bank transfer, an e-commerce purchase, or a social media post. ACID keeps everything running smoothly behind the scenes. Thank you so much for watching, everyone. I hope this breakdown of ACID transaction helped clarify how these principles keep your data safe and reliable even in the most chaotic situation. If you found this video helpful, don't forget to give it a like, and your support helps the channel grow and allow us to keep bringing you such more valuable content. And if you haven't done so yet, hit the subscribe button and ring the bell so that you never miss another video. We have got plenty more content coming, especially around backend engineering, including topics like database indexing and optimization. So don't forget to join our growing community on Telegram as well, the Prep10 Telegram community, to get the latest job and internship updates. You will find the link in the bio. Thanks again for joining, and I will see you in some other video.